Okay, so today we'll be going over the Intro to Ecology lab. This lab comes in two parts. So the first part is a game called Ecology Jenga. The second part you'll be going over species interactions. So first, of course, we'll cover Jenga. So this is a game that I've used in my Bio 100 classes, and I was introduced to it actually when I was taking ecology during my undergrad, and my professor used it then, and she's given me permission to use it now. And so how it works, you have a Jenga set, and the bottom 11 rows represent primary producers. They each have a green dot on either side, and the green dot, of course, is to help signify plants. But before you give that away, I think it'd be best if you covered what a primary producer is, and you can compare that with a consumer, and you can even go into a primary consumer, secondary consumer, so on and so forth. And so primary producer, how I like to lead into that is ask, what kind of organisms produce their own food, and that usually gives it away pretty quickly. Anyway, so back to this. So your primary producers are on the bottom. The lab calls them herbivores, but you can also call them primary consumers, are on the top. And then what will happen is each lab group has a die, and so they roll their die, and then they follow whatever the rules say on the table in their student guide. So I rolled a 3, and with 3 you have to remove 6 primary producers. So I guess I'll go ahead and show this. Rules of Jenga apply: only use one hand, only remove one piece at a time, stack your pieces back up, and then for these rules, don't let students play with the ones that they've stacked back on top. They can only play with what's on the bottom. Okay, so removing 6. We'll see how this goes. Anyway, so you'll go on and play throughout, just following the rules. If they roll a 6, they need to draw one of these cards. So the 2 options on the cards are: first, remove a Keystone Species. With this, they remove 2 Jenga pieces from any level, and then remove 2 pieces from an adjacent level. And then with a dominant species, they have to remove half of the remaining primary producer pieces. And so obviously that's where things get a little complicated, and get a lot harder. This is where towers will start collapsing a lot more quickly. And so just a few side notes. If a lab group's tower collapses like right off the bat, so say they had to remove a dominant species really quickly, or maybe they rolled something like this and then they had to remove a dominant species and their tower collapsed way sooner than anyone else in the room. Sometimes I'll let these groups run the simulation again, just so that they aren't twiddling their thumbs. If you feel comfortable with that, that's great. If not, you don't have to. But if like the first group falls and then everyone starts falling at the same time, don't let them go again, just so then everyone's kind of on the same pace. There was something else. And I think that's it. Oh, just kidding. And then also have your students count the number of turns that they take, or record them. Number of turns that the whole group takes, not just an individual. And then they also need to know anytime that they use one of these cards. Okay? So once all of the group's towers have collapsed, we can now have a discussion. So the first part of the discussion is just going through a few definitions. So the first definition is community ecology. Before this, I like to cover ecology as well. So I like to, of course, break up the word eco and ology. Ology is obviously the study of. And then at this point, I like to ask students what other words have this root eco. So they'll probably come up with economy, economics, and that's what you're shooting for. So you can backtrack a little bit and say, you know, what in the world do economy and economics, what does that have to do with ecology? Like, two completely different worlds, right? Opposite sides of campus. But you can take a step back and introduce them to the Greek root oikos, and this root actually means household, and so economics is actually like household affairs, managing household affairs. Ecology is the study of households, so looking at how species interact in their home, how they make their home, where they find their home, where they get food to survive, where they get food to help other members of their household survive, so on and so forth. And so that's how that all ties in. Now going back to community ecology, this is the interaction between all living species in a given space. Okay? So make sure you cover that. Next is dominant species and keystone species. Best way to do this is talk to the groups who pulled one of these cards. So if there is a group that pulled the dominant species card, ask them, okay, what happened? What did this do to your tower? What did the card say? The card says, of course, remove half of the remaining primary producer species. So then try and have them pull the definition together. And the definition, just so that they're all on the same page once they discuss for a minute, the definition for a dominant species is any species, or the species that has the greatest biomass in the given area. So you can give some examples like the redwoods in the redwood forest, or mangrove trees in tropical tidal swamps, things like that. Another thing that I like to tie back to is if you look at a satellite image of the Earth, what color is it, right? Like the land portion's mostly green, right? So you can derive from that that dominant species are oftentimes plants because they really take up the most biomass in a given area. So keystone species, again, this was remove 2 Jenga pieces from any level and then remove 2 pieces from an adjacent level. With this, again, ask groups that pulled this card about their experience, how it affected their tower, and what they think it could mean. You could also, if you want, pull this into like the Book of Mormon. So the keystone species is really like the species that holds it all together. You can even use the arch example, and the keystone is the top piece of the arch. And so I guess the official definition is that keystone species is a species in which other species in an ecosystem depend upon, so much so that the ecosystem will radically collapse or change without that species. So you can give a few examples. I've provided some links in the instructor guide that you can use those if you'd like. Okay, so once you go through those definitions, the next questions are, how did removal of an interactive species, so that refers to the cards, affect the stability, and was collapse inevitable when these were removed? One thing to note here, your groups, obviously not all of them will pull a card, and so with those groups, even if they do pull a card, even if they don't pull a card, they should still write about what pulling one of these cards, what effect that has on the tower, especially because you've been able to discuss this as a class. Okay, and then was collapse inevitable? Obviously, it's more inevitable with the dominant species than the keystone species, but the keystone species has a major effect. Okay, so explain what made the tower fall. I don't want them to just list, well, Bobby pulled out 17 primary producers. Obviously, yes, that would be a problem. But, or you can't say, oh, so-and-so was an idiot and knocked it with their arm. They need to pull this back into the terms that we've been using. So we removed so many primary producers that there wasn't a good enough base. Or by removing a keystone species that made the tower really rocky in the middle, or by removing a dominant species, again, we killed this base off, okay? So then we can go on to simulation 2. So let me pause so I can get the tower reset up.